In this video, we will discuss about Analyze Phase. Analyze Phase, Overview and Objectives. By the end of this phase, you'll be able to explain the different patterns of variation, describe inferential statistics, illustrate hypothesis testing, perform the different hypothesis tests for normal data, perform the different hypothesis tests for non-normal data. Pattern of variation. Pattern of variation, session overview and objectives. By the end of this session, you'll be able to explain multivariate analysis, discuss different classes of distribution. Multivariate analysis. Multivariate analysis. In statistical process control, one tracks variables like pressure, temperature, or pH by taking measurements at certain intervals. The underlying assumption is that the variables will have approximately one representative value when measured. Frequently, this is not the case. Temperature in the cross-section of a furnace will vary, and the thickness of a part may also vary, depending on where each measurement is taken. Often the variation is within piece, and the source of this variation is different from piece to piece and time to time variation. The multivariate chart is a very useful tool for analyzing all three types of variation. Multivariate charts are used to investigate the stability or consistency of a process. The chart consists of a series of vertical lines or other appropriate schematics along a time scale. The length of each line or schematic shape represents the range of values found in each sample set. Multivariate sampling plan design procedure. Select the process and the characteristic to be investigated. Select the sample size and time frequency. Set up a tabulation sheet to record the time and values from each sample set. Plot the multivariate chart on graph paper with time along the horizontal scale and the measured values on the vertical scale. Join the observed values with appropriate lines. Analyze the chart for variation, both within the sample set, from sample to sample, and over time. It may be necessary to conduct additional studies to concentrate on the area or areas of apparent maximum variation. After process improvements, it will be necessary to repeat the multivariate study to confirm the results. Multivariate analysis. Tools. Multivariate analysis is concerned with two or more dependent variables, y1, y2, being simultaneously considered for multiple independent variables, x1, x2, etc. Recent advances in computer software and hardware have made it possible to solve more problems using multivariate analysis. Some of the software programs available to solve multivariate problems include SPSS, S+, SAS, and Minitab. Multivariate analysis has found wide usage in the social sciences, psychology, or educational fields. Applications for multivariate analysis can also be found in the engineering, technology, and scientific disciplines. We will learn the highlights of the following multivariate concepts or techniques. Discriminant function analysis. Multivariate analysis. Discriminant function analysis. Discriminant function analysis. If one has a sample with known groups, discriminant analysis can be used to classify the observations or attributes into two or more groups. Discriminant analysis can be used as either a predictive or a descriptive tool. The decisions could involve medical care, college success attributes, car loan creditworthiness, or the previous economic development issues. Discriminant analysis can be used as a follow-up to the use of MANOVA. Again, linear combinations of predictors or groups are provided by the researcher. The possible number of linear combinations, discriminant functions, for a study would be the smaller of the number of groups, -1, or the number of variables. Some assumptions in discriminant analysis are: the variables are multivariately normally distributed. The population variances and covariances among the dependent variables are the same, and the samples within the variables are randomly obtained and exhibit independence of scores from the other samples. Classes of distributions. Classes of distributions. Commonly used distributions include normal, binomial, Poisson, chi-square, students T and F distribution. Normal distribution has numerous applications, useful when it is equally likely that readings will fall above or below the average. When a sample of several random measurements is averaged, distribution of such repeated sample averages tends to be normally distributed, regardless of the distribution of the measurements being averaged. Binomial distribution, used to model discrete data, applies when population is large, n greater than 50, and when sample size is small compared to population. Best applied when sample size is less than 10% of n is less than 1/10 n. Sampling is with replacement, approximation to hypergeometric distribution, used to model situations having two possible outcomes. Poisson distribution, used to model discrete data, used to model rates such as rabbits per acre, defects per unit, or arrivals per hour. Can be an approximation to binomial distribution when p is equal to or less than 1/10 and sample size is fairly large. Used as a distribution for defect counts. Closely related to exponential distribution. Chi-square distribution. Not used to model physical phenomena like time to fail, etc. Used to make decisions and construct confidence intervals. This distribution is a special case of gamma distribution with a failure rate of 2 and degrees of freedom equal to 2 divided by the number of degrees of freedom for the corresponding chi-square distribution. This is considered a sampling distribution. F distribution. Not used to model physical phenomena like time to fail, etc. Used to make decisions and construct confidence intervals. Used extensively to test for equality of variances from two normal populations. This is considered a sampling distribution. Students' distribution, formed by combining standard normal random variables and a chi-square random variable. Equivalent to F distribution with 1 and V degrees of freedom. Commonly used for hypothesis testing and constructing confidence intervals for means. Used in place of normal distribution when standard deviation is unknown. If the sample size is large, n is greater than 100, the error in the estimated standard deviation is small and t distribution is approximately normal. Summary. Pattern of variation. In this session, you learned about multivariate analysis, different classes of distribution,